Welcome to part 4 of our Know Your Customer training series focused on military payloads for unmanned ground vehicles. A UGV is more than a mobile robotic platform. Its true operational value comes from the mission payload it carries. Different army formations face different threats, terrains, responsibilities, and battlefield requirements. Therefore, the same UGV platform may need to perform completely different roles depending on the unit and the mission. The key principle is simple. The UGV provides the mobility, but the payload defines the mission. Let us now explore the world of military payloads for UGVs. Welcome to part 4 of our Know Your Customer training series titled Military Payloads for Unmanned Ground Vehicles. First, we will study surveillance payloads that help unmanned ground vehicles observe terrain, detect threats, and support battlefield awareness. Second, we will explore communication payloads that extend tactical networks and maintain connectivity between soldiers, vehicles, and command posts. Third, we will introduce weapon payloads that enable remotely operated fire support while reducing the exposure of soldiers. Fourth, we will examine combat engineering payloads designed for hazardous activities involving mines, explosives, obstacles, and route clearance. Finally, we will cover logistics payloads that support resupply, equipment movement, casualty evacuation, and battlefield sustainment. Together, these 5 categories demonstrate how different payloads can transform a common unmanned ground vehicle platform into a specialized mission system. Let us begin with surveillance payloads. Let us understand the major military vision systems that can be integrated as payloads on an unmanned ground vehicle. The first is the daylight EO or electro-optical camera, which provides clear, visible spectrum imagery for daytime observation, navigation, and target identification. The second is the thermal imager, which detects heat signatures and supports surveillance during darkness, smoke, dust, and other low-visibility conditions. The third is the integrated EO and IR or infrared gimbal, which combines daylight and thermal sensors within a stabilized platform for continuous observation and tracking. The fourth system is the laser rangefinder, which measures the distance between the UGV and a selected target or terrain feature. The fifth is the laser designator, used only in authorized applications to precisely mark a target for compatible weapon or targeting systems. These systems may operate individually or together, depending on the mission, terrain, visibility, and required detection range. When properly integrated, they significantly improve situational awareness while allowing soldiers to observe hazardous areas from a safer distance. The correct vision payload must therefore be selected according to the operational role of the UGV. Let us understand the major types of mast systems that can be integrated with military unmanned ground vehicles. A mast raises cameras, sensors, or communication equipment above the UGV, improving visibility, coverage, and line of sight. The first is the hydraulic mast, designed to lift heavier surveillance payloads with high force and stability. The pneumatic mast uses compressed air for rapid deployment and is generally suitable for lighter payloads. The electric mast uses a motor-driven mechanism, providing precise and remotely controlled extension and retraction. The manual or mechanical mast offers a simpler, lower complexity solution that can be operated using a crank or mechanical locking arrangement. The foldable sensor mast uses a hinged structure that can remain compact during movement and rise quickly when observation is required. Each mast changes the vehicle's height, weight distribution, power requirement, stability, and transport dimensions. Therefore, mast selection must consider payload weight, required elevation, deployment speed, wind loading, and the operational role of the UGV. Radar is a sensing system that uses radio waves to detect, locate, and track objects, often measuring their distance, direction, and movement. Let us understand the major radar systems that can be integrated as payloads on military unmanned ground vehicles. The first is aerial surveillance radar, which detects and tracks low-flying aircraft and other aerial threats from an elevated position. The second is ground surveillance radar, used to monitor the movement of people, vehicles, and formations across open terrain. The third is ground-penetrating radar, which scans below the surface to identify buried objects, mines, and unusual ground conditions. The fourth is counter-drone radar, designed to detect and track small hostile drones approaching troops, convoys, or protected locations. The fifth is perimeter security radar, which provides continuous all-round monitoring around camps, installations, convoys, and other important assets. Mounting these radar systems on a UGV allows them to move closer to the area of interest while keeping soldiers at a safer distance. The selected radar must match the mission detection range, terrain, target type, and communication requirements. Together, these payloads transform the UGV into a mobile platform for detection, tracking, and battlefield awareness. Let us understand CBRN, which stands for chemical, biological, radiological, and nuclear threats. These hazards can contaminate an area and create serious risks for soldiers, vehicles, and equipment. The first card shows chemical sensors, which detect toxic industrial chemicals, chemical warfare agents, and harmful vapors. The second shows biological sensors used to identify airborne pathogens, spores, and other biological agents. The third card presents radiological sensors which measure radiation levels, identify radioactive materials, and help map contaminated zones. The fourth shows nuclear sensors designed to detect neutrons, fissile materials, and other indicators of nuclear threats. Mounting these sensors on a UGV allows remote detection, continuous monitoring, and safer entry into potentially contaminated environments. This reduces troop exposure while providing commanders with timely information for decision-making and protective action. We have now completed the first section on surveillance payloads and understood how they help a UGV observe its surroundings and improve battlefield awareness. Let us now move to the second section and explore communications payloads for a military UGV. Here we will understand how a UGV can help extend connectivity and support the flow of information across the battlefield. A relay antenna receives a communication signal and retransmits it, helping extend coverage beyond the range of a direct radio link. This image shows 5 common communication relay systems that can be carried by a military unmanned ground vehicle. The whip antenna relay provides simple omnidirectional voice and data communication around the vehicle. The mast-mounted relay raises the antennas to improve line of sight and increase coverage across difficult terrain. The directional panel antenna focuses the signal toward a selected location for longer-range point-to-point communication. The mesh network node allows the UGV to become a mobile part of a resilient tactical network. The satellite communication or high-gain antenna supports remote and beyond line-of-sight connectivity where terrestrial links are unavailable. Together, these payloads can help maintain communication between soldiers, vehicles, and command posts while keeping the relay equipment mobile and remotely deployable. A jammer is an electronic system that transmits radio frequency energy to disrupt, deny, or degrade selected wireless signals. This image shows 5 common jammer payloads that can be mounted on a military unmanned ground vehicle. The broadband RF jammer disrupts a wide range of communication links and hostile radio frequency emitters. The counter-drone jammer interferes with drone control, telemetry, and satellite navigation links. The IED or remote trigger jammer helps block radio signals that may be used to activate explosive threats. The directional jammer concentrates its energy toward a selected target or sector, reducing unnecessary interference elsewhere. The GNSS jammer denies or degrades satellite navigation signals within a defined operating area. Mounting these systems on a UGV enables remote deployment while reducing the exposure of soldiers to hostile emitters and hazardous locations. Jammers must always be operated under proper authorization and coordinated carefully to avoid disrupting friendly communication and navigation systems. A counter-drone system is a coordinated set of sensors and effectors used to detect, identify, track, and defeat potentially hostile drones. This image shows both non-kinetic and kinetic counter-drone payloads that can be mounted on a military unmanned ground vehicle. Radio frequency detection and direction finding identify drone control signals and help locate their source. The EO&IR tracking system visually confirms and follows suspicious aerial targets. A counter-drone jammer disrupts the drone's control, telemetry, or navigation links. A high-power microwave system uses electromagnetic energy to disable vulnerable drone electronics. For physical interception, a net launcher can capture or entangle a low-flying drone. A gun or kinetic interceptor system may engage hostile drones where authorized and operationally appropriate. Mounted on a UGV, these systems create a mobile counter-drone capability while reducing the exposure of soldiers. We have now completed the section on communications payloads and understood how a UGV can extend connectivity and support battlefield information flow. Let us now move to the third section and explore weapons payloads for military unmanned ground vehicles. Here we will understand how remotely operated weapon systems can support combat missions while reducing the exposure of soldiers. A remote-controlled weapon station, or RCWS, is a stabilized weapon system that allows an operator to observe, aim, and engage from a protected remote position. This image shows 5 common RCWS payload categories that may be integrated with a military unmanned ground vehicle. A light machine gun RCWS provides lightweight remote fire support for patrol and security roles. A medium machine gun system offers greater sustained firepower for combat support and perimeter defense. A heavy machine gun RCWS provides increased range and effect against harder targets and protected positions. The selected system must match the UGV's payload capacity, stability, power, sensors, communication link, and authorized operational role. An anti-tank guided missile, or ATGM, is a precision-guided weapon designed to engage armored vehicles and other protected targets from standoff distance. This image shows 5 common ATGM categories that may be integrated with a military unmanned ground vehicle. A wire-guided ATGM receives steering commands through a guidance wire during flight. A laser beam-riding missile follows a laser-guided path maintained toward the target. An imaging infrared fire and forget system locks onto the target before launch and guides itself during flight. A top attack ATGM is designed to strike the upper section of an armored vehicle where protection is often lower. A multi-purpose or tandem warhead system is intended for armored targets, reinforced positions, and other protected threats. Mounted on a UGV, these systems can provide remotely operated anti-armor capability while reducing direct exposure of soldiers. Integration must account for payload weight, recoil or launch forces, sensors, communications, safety, and authorized control procedures. A grenade launcher is a weapon system designed to project grenades toward targets at ranges beyond normal hand-throwing distance. It can provide area effect fire against exposed personnel, defensive positions, and selected battlefield threats. Grenade launchers may be operated individually or integrated into a remotely controlled weapon station on a military unmanned ground vehicle. When mounted on a UGV, the system can be aimed and operated from a protected location, reducing direct exposure of soldiers. The selected launcher must always match the mission, platform capacity, and applicable safety requirements. A multi-barrel loitering munition, or MBLM, launcher is a remotely controlled system designed to carry and launch multiple loitering munitions. It allows several aerial systems to be deployed from a single platform for surveillance, target assessment, and authorized precision engagement missions. When mounted on an unmanned ground vehicle, the launcher can be positioned remotely, helping reduce direct exposure of soldiers in hazardous areas. The complete system typically combines the launcher, communication link, mission control interface, and supporting surveillance sensors. We have now completed the section on weapons payloads and understood how they can support combat operations while reducing the exposure of soldiers. Let us now move to the fourth section and explore combat engineering payloads for military unmanned ground vehicles. Here we will examine how UGVs can assist with hazardous engineering tasks involving mines, explosives, obstacles, and route clearance. A mine is an explosive device placed on or beneath the ground to damage vehicles, restrict movement, or deny access to an area. The image will show how an unmanned ground vehicle can support 3 different mine-related missions while reducing direct risk to soldiers. Mine detection uses sensors such as ground-penetrating radar or metal detectors to locate buried mines and identify a safer route. Mine laying is the planned placement of mines to create a controlled obstacle, restrict enemy movement, protect a defensive position, or channel vehicles toward a monitored route. Mine laying uses remotely operated dispensers or robotic handling systems to place mines in authorized defensive areas. Remotely operated dispenser mines may be released one at a time, deposited at selected points, or distributed across a designated area. Mine clearing uses tools such as rollers, flails, or rotating cylinders to disturb, expose, or neutralize mines ahead of advancing forces. These missions require different payloads, but all depend on accurate navigation, reliable communication, and careful remote control. By performing these hazardous tasks from a distance, an unmanned ground vehicle can improve route safety and reduce the exposure of combat engineers. A manipulator arm is a remotely controlled robotic mechanism that allows a UGV to inspect, lift, move, or handle objects from a safer distance. Here we will see 5 common manipulator arm types used on military unmanned ground vehicle. The light inspection arm supports close observation and simple handling of small objects. The EOD manipulator arm provides precise control for explosive ordnance disposal and hazardous object handling. The heavy-duty lift arm is designed to move heavier loads, debris, and battlefield materials. The telescopic reach arm extends farther to access distant, elevated, or difficult-to-reach locations. The dual-arm dexterous system uses 2 coordinated arms for complex handling, repair, and technical tasks. The correct arm must be selected according to reach, lifting capacity, precision, end effector type, and vehicle stability. By keeping the operator away from hazardous objects, manipulator arms improve safety while expanding the missions a UGV can perform. Let us understand the major work tools that can transform an engineer UGV into a remotely operated earth-moving and obstacle-handling platform. The straight dozer blade pushes soil, debris, and root obstacles directly ahead of the vehicle. The angle dozer blade directs material toward one side, making it useful for clearing paths and opening routes. The dipper or backhoe arm provides articulated digging capability for trenching, excavation, and obstacle removal tasks. The loader bucket can scoop, lift, carry, and relocate loose soil, rubble, and other battlefield material. The ripper or scarifier uses strong teeth to break compacted ground, hard soil, and damaged surfaces before further excavation. Each attachment places different loads on the vehicle's chassis, power system, hydraulics, traction, and stability. Therefore, the correct tool must be selected according to the task, terrain, required force, and carrying capacity of the UGV. By operating these tools remotely, engineer units can complete hazardous work while reducing direct exposure of personnel. We have now completed the section on combat engineering payloads and understood how UGVs can support hazardous tasks involving mines, explosives, obstacles, and route clearance. Let us now move to the fifth and final section and explore logistics payloads for military unmanned ground vehicles. Here, we will understand how UGVs can support resupply, casualty evacuation, equipment movement, and battlefield sustainment. Let us understand the major types of logistics cargo that military or UGV can carry to support troops in forward areas. The first category is food and ration cargo, which delivers meals, packaged supplies, and daily essentials to deployed personnel. The second is fuel cargo used to replenish vehicles, generators, and other field equipment. The third category is ammunition cargo, which moves ammunition and combat stores closer to operating units while reducing manual carrying loads. The fourth is power and battery cargo, providing portable energy, replacement batteries, and charging support for radios, sensors, and armed systems. The fifth category combines water and medical cargo, supporting hydration, first aid, and emergency medical resupply. Each load requires suitable containers, secure mounting, balanced weight distribution, and protection against terrain, weather, and handling shocks. By carrying essential supplies over the last mile, an unmanned ground vehicle can reduce soldier fatigue, improve resupply speed, and lower exposure along hazardous routes. This image shows a casualty evacuation UGV equipped with a stretcher system to move an injured soldier from a dangerous area to a safer location. The casualty is secured on the stretcher while nearby soldiers assist with loading, handling, and battlefield extraction. By carrying the stretcher on an unmanned ground vehicle, the system helps reduce the physical burden and direct exposure of troops during evacuation. Such a platform can support casualty movement across rough terrain while keeping evacuation faster, safer, and more organized. This makes the casualty evacuation UGV an important support tool for battlefield rescue and medical response. Let us understand the major recovery winch systems that can be integrated with a military UGV. A recovery winch uses a powered cable and hook to pull, tow, or extract vehicles and equipment from difficult terrain. The front-mounted recovery winch supports self-recovery, obstacle pulling, and forward extraction tasks. The rear-mounted towing winch is useful for pulling disabled loads, trailers, or equipment from behind the vehicle. The heavy-duty recovery winch provides greater pulling capacity for heavier vehicles and battlefield equipment. A dual winch system offers more flexible pulling directions and improved control during complex recovery operations. The boom-assisted recovery winch combines pulling with controlled lifting to handle damaged or immobilized equipment. Each system must be selected according to load weight, cable capacity, anchoring, vehicle traction, and terrain conditions. Mounted on a UGV, recovery winches can reduce manual effort and keep personnel farther from unstable or hazardous recovery zones. Let us understand two fire suppression payloads that allow a military UGV to approach and respond to fires from a safer distance. The water mist or foam system carries a liquid tank, pump, hose, and remotely controlled nozzle. Water mist provides rapid cooling, while foam can help cover burning surfaces and reduce the chance of reignition. This configuration is useful for external fires involving vehicles, equipment, structures, or surrounding ground. The portable or remote discharge unit carries a dedicated extinguishing cylinder connected to an aimed discharge mechanism. It can direct the selected suppression agent toward a hazardous or difficult-to-reach location without placing an operator close to the fire. Both systems require cameras, reliable remote control, and the correct extinguishing agent for the type of fire. Mounted on a UGV, they improve access, reduce personnel exposure, and support safer firefighting in dangerous operational areas. This concludes Part 4 of our Know Your Customer training series on military payloads for unmanned ground vehicles. We have seen how different payload categories can transform a common unmanned ground vehicle platform into a specialized system for different Army missions. Understanding the mission before selecting the payload is essential for designing an effective, reliable, and operationally relevant UGV. Thank you for watching and for being part of this training program. We hope to see you again in the next video.